Hey guys, welcome to eMaths. Let's do some maths for fun. Today, we will continue to prove Fundamental Differentiation Formula for Part 3. In Part 1 and Part 2 of the series, we have proved the 8 basic differentiation rules and derivative of all trigonometric functions. As for today, we will complete this series by proving the derivative formula for all logarithmic and exponential functions. Let's complete this. But before we start, we have to first understand the law of logarithm and the natural logarithm. We just have to recall back the laws of logarithm that we learned in high school. Number one is the definition of logarithm. N equal to a power x if and only if log base a n equal to x, where a greater than 0, a cannot equal to 1. The second one is the product law, where log base a m times n equal to log a m plus log a n. The third one is the quotient law. If we have log a m over n is equal to log a m minus log a n. The fourth one is the power law. If we have log a m power n equal to n times of log a m. The fifth one involves the change of base. If we want to change to base c, log a b equal to log cb over log c a. The last one is the logarithm of any positive number a to base a is 1. These are all the laws that we will need later. Next, I want to know what is natural logarithm. Natural logarithm, written as ln, is defined as ln equal to log base of chance, where e equal to of chance, so it's definitely natural. Just kidding. Natural logarithm, written in ln, is defined as log base e, where e is Euler's constant, approximately 2.712828. Now we have all the weapons that we need to fight the big boss. Number 15, the derivative of natural logarithmic function. We let y equal to natural log of x. So y equal to log base ex if and only if e power y equals to x. Take derivative on both sides. We have this. Since when we differentiate x, we will get 1, thus the derivative of e power y equals to 1. And now I don't want e power y on left hand side, so we divide both sides by e power y. Then we have dy over dx equal to 1 over e power y. As we defined earlier here, we know that e power y equals to x. So we will replace e power y with x here and y with natural log of x. We will have derivative of ln x equal to 1 over x. Proven, number 15. But life is not always as easy. Sometimes x is not just x. The question is, what if u is a function of x and I want to find the derivative of ln u? We let y equal to ln u, like what we proved just now, dy over du equals to 1 over u. Since u is differentiable function to x, derivative of u will equal to u prime. We can write du over dx equal to u prime. Now, summon our friend, and his name is Chen Ru. Dy over dx equal to dy over du times du over dx. You see the blue color is actually 1 over u, and the red color is actually u prime. Y caught COVID-19, so quarantine y in the bracket. We have the derivative of y equals to u prime over u. We now substitute back y equal to ln u. D dx of ln u will be equals to u prime over u. And this is what we want. Moving on, we know that logarithm is the friend of exponent. And now, number 16, the derivative of natural exponential function. By definition of log base e equals to ln e power x will be equals to log base e power x. Then we bring down the power. We have x times log base e, and it is equals to x. We can write ln e power x equals to x because when we collect all the blue color. We now differentiate both sides with respect to x. D dx of x is 1, and this is my equation 1. As we proved earlier, d dx of ln u equals to u prime over u. We substitute in u equal to e power x in red color. So d dx of ln e power x will be equals to the derivative of e power x over e power x. For now, we just write like this, and we take out 1 over e power x, and this is my equation 2. Sub equation 1 into equation 2. 1 over e power x times the derivative of e power x equals to 1. We multiply both sides by e power x to get rid of that 1 over e power x on left hand side. Therefore, the derivative of e power x is still e power x. In short, this is Captain dx, and this is ex naught. Again, don't forget our friend chain rule. So the question is, what is the derivative of e power u where u is a function of x? We let y equals to e power u. Since it's undefeatable by Captain dx, dy over du will still be e power u. Same procedure as just now, we will have du over dx equals to u prime. Summon our friend, the chain rule. Copy and paste the formula. Blue times red, isolate y with bracket, substitute back y equal to e power u. d dx of e power u will be equals to e power u times u prime. So far until now, using F-Chan as a base is so convenient, right? What if F-Chan run away with ex naught? Don't worry. Just make any base become F-Chan, which is base E, because F-Chan is undefeatable. What we have to do is we sing ABC. A, B, C, D, E. So 5 steps are all we need from A to E. We let y equal to a power x, take natural logarithm on both sides. ln y equals to ln a power x. Log base ey equal to x times ln a. Change to exponent form. E power x ln a equal to y. Subtract y equal to a power x. So a power x equals to e power x times ln a. I told you we can do this in 5 steps. Right? So we will use this letter. Number 17, the derivative of a power x. We have proved that a power x equal to e power x ln a. Thus, the derivative of a power x will be equals to the derivative of e power x ln a. Let u equals to x times ln a. We write du over dx equal to ln a equals to u prime. We also prove that derivative of e power u equals to e power u times u prime. By using our friend chain rule, we will write this. And this u prime equals to blue color ln a. Subtract u equal to x times ln a, because just now we just let it be x here, right? So we will get this. Just now we also let a power x equal to e power x ln a, right? So we sub it back. We'll get the derivative of a power x equals to a power x times ln a. Proven, number 17. And finally is number 18, derivative of log base a x. Same thing, we'll change the base to e, extract blue color, and take out the derivative. Summon our long lost friend, constant multiple rule. In this case, 1 over ln a is a constant multiple because it does not contain a variable x. We have proved that derivative of natural log of x equals to 1 over x long time ago. And now we have 1 over ln a times 1 over x. Therefore, the derivative of log base a x equals to 1 over ln a times x. And finally, we are done. What have we proved today? We have differentiated all natural and unnatural logarithmic and exponential functions. And this is the end of fundamental differentiation formula. For the next series, I will be proving another headache during high school, which is the trigonometric identities. That's all for today. See you guys in the next video.